Hello everyone, welcome to our group assignment presentation. Today we are diving into a topic that goes beyond the laboratory or industrial setting. It's about our safeguarding our well-being and the world around us. Before we get started, I will introduce you to our precious teammate. Grab your notes, get comfortable, and let's embark on this journey together. So buckle up and let's make the most of our time together.
Now we're going for the introduction of our topic. Firstly, I would like to talk about the introduction. Chemical waste encompasses hazardous byproducts from industrial, laboratory, and household activities. It contains compounds that are hazardous to both human health and the environment, such as heavy metals, solvents, and pharmaceuticals. Improper handling, storage, or disposal of chemical waste can lead to serious environmental pollution and health risks. The proper chemical waste management and waste reduction strategies are crucial for protecting human health, preserving the environment, and maintaining a sustainable and safe future.
Definition of chemical waste. Chemical waste is any excess, unused or unwanted chemical, especially those that cause damage to human health or the environment. And it includes various types of chemicals that are no longer needed and require proper disposal. Examples of chemical waste. First, expired or unused medicine. Pharmacy that have expired or are no longer needed should be disposed of properly to prevent them from entering the environment. Second, laboratory chemical. Unused or expired chemical from laboratory, experiment or research activities fall under chemical waste. Next is solvent. Using solvent from industry process or cleaning activities can be considered as chemical waste. They may include paint thinners, LINGGI or other solvents used in manufacturing. Lastly, cleaning agent. Chemicals used for cleaning purposes such as bleach, ammonia, and other household cleaners can become chemical waste when they are no longer needed or have expired.
Moving on from chemical waste, our next stop is the critical realms of chemical handling and storage. In this segment, we'll dive into the crucial aspects of handling and storing chemicals safely, ensuring proper procedure minimizes risk and protects both people and the environment. First and foremost, always prioritize your safety. Wear the right personal protective equipment or PPE, including gloves, goggles, and lab coats. This vary depending on the chemicals you're handling. Before you start, get familiar with the Material Safety Data Sheets (MSDS). These sheets provide vital information about hazards, safe handling, and emergency. And remember, avoid cross-contaminations. Use dedicated equipment for each chemical to prevent unexpected reactions. No matter how careful you are, emergencies can happen. Be prepared with a spill response plan. Fire safety is critical. Flammable chemicals should be stored in fire-resistant cabinets. Don't forget your fire extinguisher and know your emergency exits. Regular trainings and drills are a must. Ensure everyone knows what to do in case of emergency. It could make all the difference. Next, let's talk about the tools of the trade. Your containers use the right one made of compatible materials. And remember, inspect them regularly for damage or leaks. Consider secondary containment for an added layer of safety. Proper storage, shelves and racks are also crucial to prevent spills and ensure stability, especially for heavier containers. And there you have it, the essentials of handling and storing chemicals safely. Whether you are in lab or industrial setting, these practices protect you, your colleague, and the environment. Navigate through the world of chemical management. The concepts of segregations become paramount. Stay with us as we discuss how proper chemical segregations can prevent potential hazard and ensure a safer working environment.
Chemical segregation. Chemical segregation is when incompatible substances are separated to reduce the risk of the chemicals reacting with each other. All chemicals must be classified for the appropriate hazards and stored away from incompatible chemicals. Alphabetizing chemicals is not permitted as the sole means of chemical storage. Each group of chemicals must be stored within secondary containment capable of holding the full contents of the largest container or at least 10% of the total volume of all containers in it. Clean equipment and surface regularly to prevent reaction from cross-contamination. Hazard classification of chemical segregation. Chemical reagent bottles should be labeled from the manufacturer. Older or smaller bottles may not have hazard clearly marked. Begin by separating out inorganic chemicals from organic chemicals. Next, separate the solid from liquids for each group. For instance, solids, inorganic or organic. Separate water, reactive chemicals, flammable solids, and oxidizers into group. Identify corrosive chemicals, separating acids from bases. Separate toxic and irritant chemicals from the remaining non-hazardous chemicals.
I will explain 5 ways of transporting chemical waste. In the realm of chemistry, the safe handling and transportation of chemical waste demand meticulous protocol and practices to mitigate potential risks. Firstly, prioritizing ventilation is paramount. Transport chemical waste exclusively in well-ventilated areas to minimize exposure to hazardous fumes. Employing fume hoods or ventilation system as necessary. Stability during transport is a critical consideration, necessitating the secure fastening of containers to prevent tipping or breakage, coupled with appropriate tailing or support to ensure overall stability. Furthermore, a proactive approach involves the regular inspection of transportation container for signs of damage or wear, with prompt maintenance as needed to guarantee their integrity. Understanding the chemical compatibility of substance is equally crucial, mitigating the risk of creation of hazard during both storage and transportation. Secondly, the mantra of avoiding the mixing of incompatible substances enclosed as a fundamental guideline. The choice of container carries significant weight. Employ chemically resistant container tailored to the specific waste being transported.
Next is disposal method. First is chemical recycling. Some chemical can be recycled or reused. This is an environmentally friendly option that reduces the overall demand for new chemical and minimize waste. Second is incineration. Incineration involves burning the chemical at high temperatures to break them down into less harmful substance or ash.
Now, let's look at the third disposal method, that is neutralization. Neutralization is a chemical process that involves treating acid or basic substance with other chemicals to eliminate or reduce their harmful properties. And the last is landfill disposal. Landfill disposal is one method for handling certain type of chemical waste. However, it is generally considered a less preferable option due to environmental concerns.
In conclusion, safe chemical disposal is essential for protecting both of people and the environment. It involves various methods such as chemical recycling, neutralization, and chemical treatment. The choice of the disposal method depends on the type of chemical and potential impact on the environment. Regulatory bodies play a crucial role overseeing and enforcing proper disposal practice on ensure safety and environmental protection. By implementing these methods are adhering to the regulation, we can minimize the risk associated with chemical waste and safeguard our well-being and the health of our world.
If any questions need further clarifications or want additional resources, feel free to reach out. We are here to support your journey towards responsible chemical management. Together, we can make a lasting impact. Once again, Thank you for your time. Stay safe, stay responsible, and let's continue our working together a healthier, safer future. Goodbye.